Elon Musk just announced a plan to build 50 times the entire world's current AI computing power, and he is already hiring. He calls it Terafab, a $20 to $25 billion chip factory in Austin, Texas, jointly built by Tesla, SpaceX, and xAI under one single roof. The goal? Produce 1 terawatt of computing power every single year. The entire world right now produces only 20 gigawatts of AI compute. Musk wants 50 times that, and he is already posting the job listings. Chip engineers in California, silicon engineers in Texas, paying up to $338,000 per year. With one catch: 7 days a week, 24 hours a day, on call at all times. Welcome to working for Elon Musk. But here's what most people are missing about Terafab. This is not just about chips. This is about Optimus robots, SpaceX, and something Musk calls a galactic civilization. Today we are breaking down exactly what Terafab is, why Musk is betting everything on it, and what it means for you. Welcome to AI Controller. And this might be the most ambitious project one human being has ever attempted. Musk's problem is simple. He needs chips, an insane amount of chips, more than Samsung, TSMC, and Intel combined can currently produce for him. He went to TSMC and Samsung and said he needed them to scale up dramatically. Their answer was that they expand slowly. The chip industry is cyclical. They cannot do it. So Musk's response was exactly what you would expect. If they will not build it, he will build it himself. From scratch. Terafab is different from every chip factory on Earth in one critical way. Every other factory either designs chips like NVIDIA or manufactures chips like TSMC. Terafab does both, under one roof. Elon Musk said at the press conference that this integrated model of development and production has no precedent in the world. Nobody has ever done this before. The factory will produce chips at 2 nanometers, the most advanced process node in existence. And it will produce both logic chips and memory chips in the same building. 2 completely different chip types. One factory. The initial cost is $20 to $25 billion. But UBS analysts estimate the final cost could reach $300 billion. Now here's where it gets really interesting. What is Elon Musk going to do with 1 terawatt of computing power every year? Tesla gets the first category of chips. The AI5 and AI6 chips, optimized for edge computing and inference, will power Tesla's FSD self-driving system and the Optimus humanoid robot. Musk predicts that Optimus robots alone will require between 10 and 100 times the chip demand of Tesla's entire car business. He plans to release the first commercial Optimus robots in 2027, and he believes they could eventually outnumber humans on Earth. But here is the number that will shock you. Even with all of Tesla and Optimus's demand, that only accounts for 10 to 20% of Terafab's total output. The other 80%, 800 gigawatts of computing power, goes to SpaceX, and not just data centers on Earth. Musk has a specific reason why AI computing must go to space. The entire United States only generates 0.5 terawatts of electricity. There is simply not enough power on Earth. In his own words, artificial intelligence in space is obviously the only way to scale. Elon Musk's vision includes AI data centers in orbit, a space station on the moon as a launch base to other planets, and eventually consumer space tourism. SpaceX has announced plans to launch 10 million tons of mass per year into orbit using Starship V3, and they need 1 billion Optimus robots to build it all. SpaceX called it in their official announcement the next step on the way to a galactic civilization. And Terafab is the foundation that makes all of it possible. Now let us talk about the jobs. In Palo Alto, a module process engineer for lithography, Tesla requires at least 10 years of top-level semiconductor experience. Base salary from $88,000 to $240,000 with stock bonuses. In Palo Alto, a process integration engineer responsible for advanced logic chips. Salary up to $338,280. In Austin, Texas, silicon engineers and a technical project manager who has managed capital projects over $100 million. SpaceX already has about 60 open positions in their Silicon area. The requirement everyone is talking about: 7 days a week, 24 hours a day, on call at all times. Now let us be honest about the challenges. Semiconductor manufacturing is the most knowledge-intensive industry on Earth. TSMC's advantage is not equipment. It is decades of accumulated know-how. Terafab has to compete with TSMC, Intel, and Samsung for the exact same specialized engineers in a market that already has a severe global shortage. TSMC spent $117 billion building its current facilities, and Elon Musk wants something 50 times larger. Even at twice TSMC's efficiency, that is still a $3 trillion investment. SpaceX's $50 billion IPO is only 2% of what Terafab theoretically needs. But here is the most important thing to understand about Elon Musk. He has announced impossible goals before, and then built them anyway. Reusable rockets were impossible, until SpaceX landed one. Electric cars at scale were impossible, until Tesla built the Gigafactory. Calling his bets impossible has a poor track record. If Terafab delivers even 10% of its stated goal, it still produces more AI computing power than the entire world does today. For investors, the two ways to get exposure right now are Tesla stock and EchoStar, which hold a significant SpaceX stake ahead of the IPO this summer. Terafab is either the most important project in human history or the most expensive failure ever attempted. Either way, you needed to know about it. That is your complete Terafab breakdown. Comment below. Do you think Terafab succeeds or fails? Or what about other companies that already build chips? Subscribe to AI Controller for weekly breakdowns on AI, robotics, and everything in the frontier technology. I will see you in the next one.